Hi, my name is Selena Roman White, and today I'm going to be presenting about an important topic going on in the frack industry. Each year, fracking consumes between 70 and 140 billion gallons of water in the U.S. alone. Fracking is an extremely water-intensive process. Each well will consume between 2 and 4 million gallons of water over its lifetime. Now, a lot of this water returns to the surface as flowback, water that comes back before you begin producing natural gas. However, this flowback must be treated as a waste because it contains chemical additives and the minerals and other things picked up while it's down in the well. So it can't be automatically just reused back in the fracking process. With parts of the U.S. already experiencing water scarcity, it's important that we reduce our use of fresh water. There also are environmental implications where if this water needed to be shipped off to a treatment plant, there's associated air pollutions and the lake. So there has to be a better option than just not recycling the flowback water. You may think that recycling would cost companies money, but it's actually the opposite. It's been shown that as much as $370,000 could be saved per well by recycling and reusing this water. Currently, most companies are using a process called reinjection, where the water is just reinjected back into the ground and stored down there before it's treated, and so the water can't be reused if you do that method. There are a lot of methods though that could be used to completely recycle, clean the water, and actually reuse it in a new well. And I have a lot of those listed here at the right. They have different costs and remove different amounts of chemicals, but the one I'm going to focus, the one that I think is the best option, is electrocoagulation, or EC. EC works by having the water flow over electrodes with an electric current applied, which causes redox reactions. So these redox reactions cause the pollutants in your water to coagulate and either rise to the surface as a stable flock or sink to the bottom as a sludge. This picture shows the reactions that are going on. So you have your electrodes and the water is flowing over, your pollutants are going to coagulate, and the redox reactions form H2 gas. The bubbles help the pollutants rise to the surface and create a flock, or the pollutants can simply settle down to the bottom as sludge. EC is a continuous process, which is great. It can treat as much as 20,000 gallons of water per minute. It also offers reduced operating costs, low sludge production, low energy requirements, and reduced need for chemical reagents, because a lot of the other treatments use additional chemicals, which are problems all on their own, so EC does not need any additional chemicals for treatment. Of course, there are issues with EC. There's a phenomenon called passivation, where accumulation on the surface of the electrode of materials, and eventually the electrode is completely blocked. So you can't have any redox reactions occurring at that time. This can be prevented with proper maintenance though. Additionally, the nature of the redox reactions is that the metal electrodes are slowly reacted away. So eventually the electrodes would need to be replaced, but again, proper maintenance will keep the system running fine. I have two images. This shows what a typical EC treatment might look like, tanks of water with the water flowing through over the electrodes. And in this image, this is flowback water, and then it was treated with EC, and this is the result. So visually, you can just see how clean you can get this water. EC has been shown to remove over 98% of turbidity, hydrocarbons, lead, chromium, and BOD, things that are bad. You don't want them in your water if you're going to be reusing this water for new frack jobs. EC has the whole package. Under optimum treatment conditions, electrocoagulation costs approximately 86 cents per cubic meter. Compare that to traditional reinjection, which I was talking about, which most companies are doing right now. Traditional reinjection costs between $4.73 and $6.29 per cubic meter, astronomically more money. The cost of operation for EC is low, and the materials themselves, aluminum and iron, which are generally used for the electrodes, are relatively cheap materials. Yes, there are challenges with electrode passivation, but this can be overcome with maintenance. There's also the issue of scale-up. Because EC currently isn't used on frack sites, there would need to be some research into how to put these plants on the site so that the water could be treated right there. But they could do pilot plants, and so it's not a large issue, it's just something that will have to be researched. And lastly, EC is able to get the water as clean as we need it. The removal is there, the technology is there, and it's cost effective. It would actually end up saving companies money in the long run. So I think it would be greatly beneficial for companies to implement EC programs on their sites, help reduce the environmental impact, help reduce the water stress, and actually save them money in the long run.